Hello there guys and welcome to our next class for the fourth unit. This is a class that is part of Beehive School and 7th grade. Our subject is science and we are working on week number 33. So let's go over our presentation and let's start with our end in mind. Students will be able to summarize lesson 3, which is a pretty simple objective for today. And here you have a summary of the activities that you need to complete. Number 1, summarize lesson number 3. Make sure to focus a little bit more on pages 150 and 151 when you are reading the content from here. Then, number 2, complete the book exercises. And number 3, create a compilation of your work in one document. It can be either Word or PDF, and upload it to Educativa. All right, so let's continue. And we're going to start by talking about volcanic landforms. You are going to find the topic from pages 146 to 151. And we're going to start by saying that lava has formed most of the islands of Hawaii. In fact, most of the continents we know nowadays had formed from lava and volcanic activity. So if we remember a little bit about the way Earth structure actually was formed millions of years ago, what happened was that originally there was a lot of volcanic activity, and it was absolutely everywhere around the world. And since there was a lot of magma that was coming out of the mantle from the crust of Earth, and it actually went through a process of cooling down. And right after it, let's say it cooled down to a point in which a lot of rock was formed. And nowadays, we actually know all of this as continents. All of that lava that was actually cooled down, that was somehow fossilized. It actually was part of the creation of the continents. And if we go back to the structures of volcanoes, we're going to find something that is called a caldera. And it forms when a volcanic eruption empties the lava chamber from a volcano, and it collapses inwards. A lake can form from the caldera. So calderas are going to form right after volcanic eruptions, because you know that when a volcanic eruption takes place, a lot of magma is released, and of course it is turned into lava. What's going to happen is that if this eruption is way too massive that it actually empties all of the magma chamber that the volcano has, then the volcano is going to be empty. It is going to be a dead volcano, let's say, or an inactive volcano. So what's going to happen is that, imagine that this is the structure of the volcano, right? So at some point, like at the top or the crater is going to collapse. So it's going to come inwards, let's say. And of course, we're going to get like a bowl-like structure, which is the one that you can see in the picture on the left. In the picture, you can actually see that there is a lot of water. And it can actually happen if, of course, the structure is stabilized. And after a very long time, the crater of the volcano is going to gather or contain a lot of water. And then a caldera is going to form. We continue and we can talk about cinder volcanoes. And cinder volcanoes are quite interesting. They are just like the one that you can see in the picture. And they have the shape, I'm sorry, there should be an S, a shape of a small mountain or a hill. And it is known as a cinder cone. And due to the high amount of silica in the lava, their eruptions tend to be explosive. So these cinder volcanoes tend to be smaller than other volcanoes. And they usually have a bigger crater than the rest of volcanoes, just like the ones that you can see right there. And of course, just like it was mentioned, usually they are going to contain a lot of silica inside their magma. So explosives, also the eruptions are going to be usually explosive. And now we're going to continue with composite volcanoes. Composite volcanoes are tall, cone-shaped mountains in which several layers of lava and ash alternate. So in order to explain this a little bit better, and of course in order for us to understand it, we have to look at the picture right here. And I want you to take a look at the layers or the lines that you can see right here. There are some that are whitish, some others that are a little bit gray. And you can notice that they are like alternating. First of all, you have like a whitish layer, then you have a gray layer, then so on and so forth. You can continue with the same pattern. And what happens here is that lava and ash are alternating. Remember that when lava cools down, it can form several minerals as well as several rocks that are going to be hard, let's say. So we can have like lava and ashes, so on and so forth, until a volcano is structurized in this way. And the silica content of the magma can vary, which means that sometimes we are going to find high amounts of silica inside the lava, or we can find low amounts of silica inside the lava. Okay, so we continue, and we have a shield volcano. We have shield volcanoes, and these are probably some of the most interesting ones, because probably you're wondering, hey teacher, but right there in the picture we can't actually see a volcano. But let me tell you that there is one. So we have that they are low elevated volcanoes that tend to have a flat shape. So actually, the sort of mountain or sort of hill that you can see in the background, that's a volcano. And that's weird, right? Because we usually think that volcanoes are going to have like a mountain shape structure, let's say. But in reality, they are like a little bit flatter. They just have a low elevation, of course, comparing them to other volcanoes. And most volcanoes that form in the ocean floor are shield volcanoes. So if we go to the ocean and we start analyzing the ocean floor, we're going to find a lot of these volcanoes. They are less common in the surface, let's say, or in the continents, but sometimes they can actually form. And right now we're not talking about volcanoes anymore, but these are some, let's say, it is a structure that is similar to a volcano. But it isn't a volcano in itself. It is known as lava plateaus. It forms when long cracks expose lava and let it flow through extended locations. So, just that you can see right here, there was like a crack on the Earth's crust, and from that crack, a lot of magma was being exposed. And because lava was being exposed, it will start traveling for long distances. It happens for a very long time. And after it solidifies, it is possible to find separated lava streams. So, just like in the picture, you have like a main lava stream, let's say, from the main crack that is actually expulsing the magma from under Earth. And later on, after it starts to cool down, then you can find separated streams of lava that start traveling around. Okay. And lastly, please make sure to go to pages 150 and 151. You have to read them, please. And they are going to be completed during the live session. So make sure to read them so you can actually have some background knowledge on what they talk about. But the exercises will be completed during our live session. That's about it. So thank you guys for coming, and I will see you around. Goodbye.